So let's look at one final example involving triple integrals. So let's say I want you to evaluate the integral from 0 to the square root of pi over 2, from x to the square root of pi over 2, and from 1 to 3 of sine y squared dz dy dx. So if you look at computing this first integral here, there's no z. So when I get that, integrate that, I'll get the integral, right, of, you'll get a z sine of y squared from 1 to 3 square root of pi over 2 x square root of pi over 2. So you get 2 sine of y squared dy dx. And you can pull this 2 out in front. So maybe I'll go ahead and do that. And now you need to integrate sine of y squared. And we don't know how to do that. So we're stuck. We can't find this. So what that means is, in particular, we're going to need to change the order of integration. So if we want to do that, we've got to look at our bounds on our integral and describe our region in a different way. So here, the bounds told me x was between 0 and square root of pi over 2. Y was between x and square root of pi over 2. And then z was between 1 and 3. So I'm going to look at this region here. Z is between 1, 3. And then I'm looking at y. My bottom bound for y is y equals x. So that's coming diagonally out of the origin here. And then it's stopping at square root of pi over 2. So I'm looking at this essentially prism region here. So what I'm going to do is I'm going to project this onto the xy plane. So if I look at the portion that's on the xy plane, that means I'm just looking at these two bounds here. So x goes between 0 and the square root of pi over 2. And then y is bounded by y equals x. And then the square root of pi over 2. So here's my region here. And so what we're going to do is we're going to describe this in a different way. We want to describe it in the other way. So we're going to have first bounds on y that are fixed numbers. So y is between 0 and square root of pi over 2. Now x is bounded by, well, it's going to be y on the upper bound, and then x equals 0. So this one corresponds to x equals y, And this one corresponds to x equals 0. So now that I've switched my x and my y, I can now switch them in my integration here, my order of integration. So 0 square root of pi over 2. Now it'll be 0 to y. Z still goes from 1 to 3. Sine of y squared, and it'll be dz dx dy now. So let's see, we switched x and y in our order, and does that really help us here? So 0 to y, you'll get sine of y squared, c still. So you'll still get a 2, which I'll go ahead and pull out all the way to the front. Sine of y squared dx dy. Now because it's dx and there's no x here, this whole thing is like a constant. So this is 2 times the integral. So this is sine of y squared x. And now in place of x, you're going to plug in y and 0. So this will be sine of y squared times y. And now you can get away with doing a u substitution here. So if you did your u substitution, you'll get a minus cosine of y squared here. So I get minus cosine of pi over 2 minus, it'll become plus cosine of 0. Cosine of pi over 2 is 0, but cosine of 0 is 1. So my final answer is 1 here. So in some particular cases, the order of integration does matter. And sometimes with the order that's given, you can't actually compute these triple integrals. So what you need to do is instead switch the order of integration, and then you'll be able to compute the integral, the triple integral.